everybody, my name's Rob and welcome to the channel. Today's video is going to start off a little bit weird. I'm just warning you now, okay? Because what I did was I started building my Victron system and I had this idea. Why don't you put this on YouTube? Some people might get something from this. They might learn something. They might get some practical skills. And I went, nah, not doing that, no. And then I thought about it a bit more. Yeah, all right. So here we are. We're putting it on YouTube. Now, what we're going to be looking at is we're going to break it down to the very basics. And we're going to have a look at the design. We're going to have a look at the cables. We're going to have a look at the length of the cables, the current that's going to be going through those cables, the load at the other end of it, and we're going to come up with a cable size. We're going to do all of our calculations and we're going to work it all out. We're going to work what type of wire we need. Cable, wire, what type we need. Is it copper? Is it tin copper? Are we going to use stranded or are we going to use solid? We're going to have a look at that. We're going to have a look at the fuses. So we've got to protect those cables. So we need to use fuses or circuit breakers. We're going to have a look at the size of the fuses. We're going to talk about the size of the fuses. How we come up to the conclusion that this is the size of the fuse that we need for this particular wire. So after that, well, this might not necessarily be in order, but the other thing we're going to look at is cable management systems. Cable management systems are very, very important for the protection of cables and wires in a circuit. The cable management systems are there. If you drop something, or let's say you've got a wire going through a wall and it's in a caravan and you're driving down the road and that wire's going brrr, what's going to happen is that insulation on that wire is can potentially wear down, and if that wears down then it can cause faults. If there's no insulation, you can get some arcing and sparking. What does arcing and sparking lead to? Fire. So we want to avoid that, and to avoid that we plan and we use cable management systems. Cable protection, mechanical protection against that sort of thing, dropping something, pushing something up against it, or the vibration. Going to look at the fuses, the size of fuses. So then we're going to talk about the standards, the acts, the regulations that we have to adhere to. Now I'm in Australia, so that might be different to what you've got to consider wherever you are on this planet. And I don't know where that is, so you've probably got to do a little bit of research and have a little bit of a think about that. Wonder how that applies to me. So I'm going to have a look at the Australian standards here. I'm not going to go into too much depth in it, but I'm going to have a look at it and break it down and how that applies to my installation, and specifically my installation. I will talk about the caravans and what you need to consider there, because what I want to do, even though a boat is excluded from AS 3001.2 2022, I want to take that into consideration anyway, because I want to do the very best thing that I can do to protect the boat and the electrical systems. So we're going to have a look at it. We're going to have a look at the crimping systems. We're going to have a look at the heat shrink systems. Now I like using glue lined heat shrink, and the reason I like glue lined heat shrink is, yeah, it's got glue in it. So what does the glue do? The glue bonds itself to the PVC or the insulation of the cable, and basically, sealing itself up very, very well on the wire itself. And we're gonna go through all of those sorts of things anyway. So I hope you get something out of this. I hope you enjoy it, and if you do, please subscribe. Please hit the notification button, because there's going to be plenty of other content coming up. I'm going to just keep going on with this electrical. I've even thought about setting up a different channel, a separate channel, because originally Precious Edge was about boating and fishing, and now I've gone down the electrical side and I'm enjoying it. So let's see how we go. I may still set up that separate page, and if you think I should, please comment. Just say, hey Robbie, you should probably separate the two channels, because that's electrical, that's fiberglassing and boating, and they kind of relate but they don't. So look, thank you very much for watching this video. I hope you get to the end of it, and I hope you learn something, and I hope you get maybe some new practical skill sets. Excellent guys, thank you very much. And yeah, again, just be aware that the start of it a little bit sort of, I watched it and went, maybe I should change that. I thought, nah, leave it in there. You know, people are used to seeing weird stuff on YouTube, so it's still there. All right, guys. Thank you very much. Thanks again, eh? In my last video, I talked about the design of my electrical system, the electrical system that I'm going to be setting up in my boat. These systems are basically going to be 12-volt systems, and you can use these in caravans, boats, four-wheel drives, campers, anything that you like. Don't just think that this is just about boats, because it's not. So what I'm going to be doing today is I'd previously started to set up my Victron Multiplus 2 and all of the other equipment in a junction box. Now the junction box, because it's going into a boat in an area where it could potentially get spray and wet, I wanted to protect it. Now I'm still going to go down the path of testing everything. I'm basically going to run the Victron up, I'm going to connect all sorts of loads to it, and I'm going to measure the temperature inside the cabinet. But today, the whole idea of today is what I want to do is I'm going to pull it out and I'm going to go through the process of what I did, how I got it to this stage. It's not finished, obviously. It's very, lots of different things that still have to be finished off on it, but I need to get it done. So that's what I'm going to be doing over the next few days, and I hope you get something out of this one. Essentially, I hope to break it down into very small bite-sized pieces, and I'm going to explain all of the different things that I'm using, all the different types of wires, the cables, the cable protection, the ducting, why I'm using certain ducting, the circuit breakers, the fuses, so that if you don't understand it, then hopefully we can go on a bit of a journey and see what you can get out of this. Let's get into it. So what I'm going to do first off is I'm going to pull all of this apart. I'm going to pull that Multiplus out of there. There we are. There's no cables tied up to it or anything else at the moment, so they can basically go down there on the floor, and we're going to have a closer look at it and see how let's see how I put it all together. Now a lot of other people are going to do things differently, I get that. There's hundreds or thousands of ways that you can do these things. There's not just one way. This is just how I've done it. This enclosure here is basically set up for switchboards. It's designed to have a backing plate bolted to the back of it. That's why I've got that aluminium plate on the back, and I'm just about to, what I'm going to do is going to take that out, because I just think you're going to be able to see it a lot better if I get that out of there, and we can have a bit of a play. Alright. The idea originally was that this backing plate was going to go into an IP rated enclosure to protect all of my electronic equipment, all the electrical equipment, and make sure that it was protected from water, spray, because this one's going on a boat, we need to just make sure that it's protected. There are IP ratings. We'll talk about the IP ratings a little bit later. And I've got an aluminium backing plate. The idea of the aluminium backing plate is to be used as a heat sink. Because I'm putting high current, high load electronics and equipment on this, then I wanted it to be able to disperse the heat a little bit more within that enclosure as well. So that's the idea. That's the reason that I've used the aluminium. So this is the MPPT. I've got a 100/30 MPPT, and you can see the heat sink on the back of it. So this is what we call a heat sink. The whole idea of a heat sink is to draw the heat away from your electrical or electronic components, and to basically allow the air, the reason it's got all these fins on there is to allow the air to travel in between those fins and to cool it down a little bit. Okay, so you need that circulation of air around that to cool it down. And then my idea here, aluminium backing plate, that's aluminium, should be aluminium, I'm assuming it's aluminium, aluminium heat sink, heat shrink, I was just about to say heat shrink because I use heat shrink quite a bit as well, but that's a heat sink, right? So that's going to be screwed to the backing plate, which is going to provide that little bit more heat transfer to drag that heat away from the components, and big surface area so that it can cool down rapidly. So that's my idea for this anyway, and I'm going to test that, so we're going to have a look at that a little bit later on. We're going to test it, basically run all these components off of it and find out what the temperature's like inside of the enclosure itself, so that we're not going to have any problems with overheating or any issues whatsoever. That's why I've gone down this path. And then you'll see that all of this stuff, what is all of this? This is what we call slotted duct, and this is very, very commonly used in the electrical industry, where we've got big electrical switchboards, mechanical services switchboards, where there's lots and lots of different wires and cables coming through, and they've got to come through at different areas. So as you can see, I'll show you. We'll do some close-ups a little bit later, and what we've done. So that's it there. So that's why it's called slotted duct. You can see all the slots and everything in there. And what happens is, little cover goes over the top of that. Alright, so it keeps your cabling nice and tidy within the enclosure itself, or wherever you're going to have this. And it also provides what we call mechanical protection. Mechanical protection is there to protect cables and wires from getting damaged. The likelihood of it getting damaged when it's inside of an enclosure is pretty slim. But if you've got this outside somewhere in your caravan, in an area where there's the potential where you could drop something on it or drop something on the wires, then it's going to save your wires from getting burnt or damaged, and then hopefully limit the exposure to any sort of faults or short circuits or problems that you could potentially have if you got that damaged. So that's slotted duct. Very, very easy to use. You just cut it to length. That's just obviously a little short piece. We've cut all of these ones to length and set it up around the backing plate to make sure that they're exactly where we need them for all the wires to turn. And what we can do is, so that's what it looks like when the lid's on. You can put the lid on a couple of different ways. I normally try and slide it on like that, and that's it. That's what it'll look like later on. The cap goes on over the top of that, and you can slide it off or pull it off like that. And the idea of it, very, very simple, is the little slots there, we break them off. So what we can do now is, if we've got cables, wires, we bring them down in through there, we bring them into the enclosure, into the duct, and they're all protected. And the other thing that I really like about this is the fact that it is slotted, and it allows air to flow through it. So it's not a full enclosure, it's not completely blocked off. You can get air circulation through there, keep your cables nice and cool. Alright, at working operating temperature without overheating and problems that you're going to have if you get lots of current going through a cable. So if you've got a wire or inside of a normal conduit which is fully enclosed, and you're drawing a lot of current through there, 100 amps, 200 amps, 300 amps, whatever it is, then that conduit has no way of dissipating that heat, or no way of allowing that heat to escape, and is contained within there. So that can create problems. Just sort of be aware of that, you know, it's important to allow airflow around your cabling system in high current, high load, high power environments. And that's it. That's slotted duct. Just keep that in mind, guys. You can get that in different colours as well. I've seen some people paint it and everything to make it look really, really pretty. This is probably the most common colour that you'll ever see in electrical installations and mechanical services switchboards, electrical switchboards. The grey just seems to be the one colour that everybody seems to love. Slotted duct. There, slotted duct, slotted duct, slotted duct. So when I went through and I set all of this up, I basically set everything out into position so that I could get my ducting and everything right, so that I could basically break out those little slots like I showed you before in my slotted duct to allow the cables to come out, the wires to come out, and now we're going to start putting it all back together. So relatively, this is going to be a lot easier than it was the first time around, that's for sure, because everything's already pre-drilled and ready to go. Nice. Geez, you're good, Robbie. Very, very good. So our MPPT I've put up in this corner. Whoopsie! Put up in this corner here. For those of you who have got, you know, like to see things perfectly level and everything, I'll get my spirit level out a little bit later and get all of that spot on. OCD, I think they call that, don't they? Something like that. There we go. You can also cheat. Oh, that's loud. Nice and tight. That's not going to go anywhere. like I said there, I'll get all that levelled off a little bit later. Alrighty, so my MPPT is now in place. I'll get my links distributor, get him in there. Same sort of thing, the screw holes are already pre-planned and set up. Just dropped one of the insulators there. We'll get that in. Screws are falling out everywhere because they're already in there. Got to try and line this up now. There you go. That should be it, I think. Yep, I think I've got that. Now, screws there. These are all stainless steel screws too. I'm not a huge fan of using stainless steel when I'm doing some of the electrical connections and everything, but in this case it's not connecting to any power, it's actually just holding my links distributor into position, so that's all fine. Okay, so there we go, our links distributor is mounted. By the way, the cover's down here, I'm just going to grab that so that you can see. That's going to be, it's going to go, which way? Yeah, that way. Links distributor, across there like that. Okay. This is pretty, I like these colours too, eh? The one thing that I really like about some of this Victron stuff, they've got some nice colours. The blue and the orange really seem to go together. Looks pretty cool. Alrighty, so that, you'll notice that I've got my cables, my wire outlets on this side, the ports on this side, so that they come into the duct, into that slotted ducting that I was talking about before. Okay, so I'm going to leave that off for now. I just wanted to show you that, to show you how pretty it looks. It's pretty cool, right? When this all comes back together, it's going to look really, really cool. Hopefully you're going to be able to look at that and go, oh, it's a pretty professional sort of installation. That's nice. I've also, something that I probably didn't mention before is these guys here, these are my DC circuit breakers. So when my PV array comes in, my cables coming in from the solar panels, they're going to go through these circuit breakers before they come into the MPPT. Just to protect everything once again, protect wires coming into there. And then we're going to set all of that up. So that's what we're going to do now, is I'll show you how I do that. One of the things that I want to point out is I've already set up a lot of my wires. The wire length is all done, my crimps are already done, and we are going to go through that. I'm going to show you exactly how I do my crimps, how I do my bootlace terminals, how I put the heat shrink over the top of it. So this particular wire here is my solar wire. So this one is going to be coming from my solar panels, my PV array coming down into this circuit breaker. Now this is a special wire. Special because it's going to be outside, it's going to be sitting on top, on top of a tarp roof, and it's the proper wire for solar panel installations. So you'll see the markings on it there. Alright, hopefully you can read that. I don't know whether this camera, this phone is focusing on that very well at all, but what it says basically is it's a 6mm squared, halogen free, low smoke, 1.5 kV DC for DC use only, so very, very clearly not for AC circuits whatsoever. Do not disconnect under load, very important, do not disconnect under load, draw an arc, spark, and you could be in all sorts of trouble. 90°C, solar DC cable, minus pole, so that's your negative pole. Alright, says it right there. Now, we're going to line this up, and what we want is a couple of millimeters of the wire itself poking out the end of our ferrule. Now our ferrules are these, and they're all set up. The size is very, very important. You've got to match the size of the ferrule with the wire that you're using, so that's 6mm squared. It says it very clearly there on the label. Color coded as well, color coded green. So I'm going to line that up. So basically what I'm going to want is a couple of millimeters of wire coming out the end of the ferrule when I've completed it. Alright, so it's alright if you've got too much length there, because then you can just cut it off, clean it up, nice and easy. And I my pliers, just work my way around this particular wire, because it's not like the PVC that's really easy to strip with our wire strippers and other tools. You've just got to work with it a little bit more. So peeling off like that. Sometimes I'll twist it backwards and forwards a couple of times, tie it on there. Okay, so that's off. And what we're going to do, we just slide that. Now we always twist our wires. I always twist my wire, the conductor itself, to make sure that when I slide this down over the top, that's quite a bit out there now at the moment, but that's perfectly fine. There's nothing wrong with that. When I slide that down over the top, I can twist it on. See that? So I slide it down over the top and just twist it on. Now I've got, like I said to you, I've got quite a bit poking out over the top, and that's fine. There's nothing wrong with that. I can cut that off. Then I get my crimping tool. So this is a bootlace crimping tool, and all we do, very easy, slide this down over the top to the edge of the insulation, and we go crimp. Job done. Easy. Do it second time if you really want to. Okay, there we go. Like I said, there's some wire poking out the end there. That's perfectly fine. Nothing wrong with that, because we can do this. Snip. It's gone. Tidy it up a little bit. Job done. Alright. So, a little bit poking out the end, but like I said, that's going to be inside of our tunnel. Inside of that. Alright. So that's pretty much it. I put heat shrink over the top of that. So this is the heat shrink that I'm going to be using. It's either, have I got a smaller heat shrink? Just, not about the same size. So this is a glue lined heat shrink. And what I'll do here is I'll show you how I do this. Snip that off. Now when I'm doing this, I'll normally do if I know I'm gonna have to be doing a few of them, I'll line them all up and basically get them all the same length and just keep cutting. So we grab that, put that wire down so I'm not fumbling so much. That. You can use your cutters, your sideys, your pliers, you can use a razor blade, whatever. The razor blade can give you a nicer cut sometimes. There you go. And what I'm going to do now is I can slide that down over the top. Alright, that's nice and loose on there at the moment. I grab my heat gun. I haven't got anything on that heat gun at the moment. There's no barrels over it or anything. And I get my Makita battery off of my screw gun. On there. These sometimes take a little bit of time to heat up, and I want it pretty hot. And what I do is line it right up with the insulation that's on the end of it. There. Put a fan on this. Alright, so what we end up with, guys, is basically something that's going to look like this. So that's your bootlace crimp, the bootlace ferrule over the top, and I can see the glue coming out of the end there. I really like to see the glue coming out of the end because I know that that's finished off and done properly. Alright, so that's that. Let's start putting all of this back together, eh? So what I've done is everything's basically to the length it needs to be. When we go to put all of this back together, it's all colour coded. I've made sure I've used the right colours. Alright, okay, there we go. That will go up into my switch panel. And notice, I hope you can see that however my radius on the wire itself isn't too great. It isn't in a right angle like that. It's got a bit of a radius to it. The reason for that sort of mechanical protection, doesn't put too much tension on it, and it's got a little bit of flexibility. It's not too tight. It can move around a little bit if it needs to. And I'm switching my circuit breaker here between both my positive and my negative. Positive up in there. There we go. Alright. Always do a pull test. Doesn't matter what it's on. Always do a pull test. Make sure it's in there properly. Okay. So that's the first two done. Boom, 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 boom. Something I probably should note here too is when we connect all of these little, all of our nuts and washers and put them all back together, there's a specific order. If you have a look in the Victron Multiplus 2 manual, you'll notice on, if you're English speaking, you'll notice on page 61 of the manual here, it's actually got an order in which the washers go down. So basically it shows the lug going down first, and then you've got the flat washer, the spring washer, and then the nut over the top of that. So I'm doing that in that order. To make sure that I follow the directions of the book as per that little pretty little picture there. The other thing is it also makes note of the torque. The recommended torque for locking them down is 12 Newton meters on the M8 nut. Now I'm not going to do that just yet, but I am going to come back and do it again later because I'm going to make some changes. I'm going to play around with it a little bit and get it a little bit tidier and clean it all up. But yeah, just a couple of things to note there, guys. Important to get that right. Woo! The other thing that I'm going to do is I'm going to put my link shunt on here. So I'm pretty lucky because this is going to space off quite well. Now I'm actually going to put my link shunt straight on the negative terminal, on the negative bus bar here, and it's going to go on there like that. I might have to break another one of those terminals off because I've moved that around a little bit. There we go. Snap that off. Get that out of the way. I might have to cut it too. Yes, I will. I'll have to snip that off. So get some sides. Simple as that. Sides. Take a little bit off. There. Cuts very well. Done. Tidy it up a little bit. And I'll screw that into position. Yeah. Righto, so there we go everybody. That's going to be the end of part 1 of this particular series. I don't know how many parts there are going to be in this series, but there may be lots and lots and lots. So I'm going to break it down as much as I possibly can, make it as simple as I possibly can, and make it very practical. So recapping on what we did is we talked about the cable and wire sizes. We will have a look at that in a lot more depth a little bit later on. Have a look at how I came up with the calculations. Most of it's done by software these days. You can just get apps and everything. You put in your current load, your cable length, and voltage drop allowed, and percentage anyway, and then it comes up with a cable size for you typically. Heat sinks, we talked about heat sinks and heats in high powered, high current circuits, how that heat is dissipated through the heat sink. We looked at cable management systems, the ducting, the reasons that we use the ducting to protect the cables, to protect them from bumps, knocks, scrapes, lots of different things, to make sure that we don't have any short circuits, intermittent faults or fire. Also looked at crimping and our heat shrink systems. But again, it was a very, very quick overview, so we will dig deeper and deeper into these things as this series goes on. So I've been waffling on for about half an hour, guys, so that's it for part one. Hope you join me for part two, and we'll see you on the next one, guys. Thank you very much for joining me today, and I'll see you soon.